Welcome to Cato SASE. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with focus on networking. Also, hit the bell icon to get notified of new videos. In this comprehensive presentation, we will explore the Cato SASE platform from an engineering perspective. Cato Networks created the first purpose-built SASE cloud service back in 2015, 4 years before Gartner officially introduced the SASE category in 2019. This makes Cato one of the true pioneers and leaders in the SASE space. SASE, which stands for Secure Access Service Edge, represents a fundamental shift in how enterprises approach networking and security. Rather than relying on disparate point solutions scattered across branches, data centers, and cloud environments, SASE converges networking and security into a unified, cloud-native service that can be delivered everywhere. The Cato platform has been recognized as a leader in the Gartner Magic Quadrant for single-vendor SASE, validating their approach of delivering true convergence rather than simply bundling separate products together. Throughout this presentation, we will examine how Cato delivers on the promise of SASE by providing secure and optimized access for everyone, everywhere, at any scale, and to any application. We will cover the core architecture, connectivity options including SD-WAN and remote access, the comprehensive security stack known as SASE 360, and the unified management experience through the Cato management application. By the end of this series, you will have a solid engineering understanding of how to design, deploy, and operate a Cato SASE environment. Cato Platform Core Components. Now let me explain the core components that make up the Cato SASE platform. The diagram shows how these components work together to deliver the complete SASE solution. At the foundation, we have the Cato Global Private Backbone. This is a purpose-built network spanning over 85 points of presence worldwide. These POPs are interconnected using multiple Tier 1 carriers, providing SLA-backed connectivity with 99.999% availability. Unlike solutions that rely on the public internet, Cato's backbone delivers predictable and consistent latency with minimal packet loss. The second component is the Cato sockets, which are Cato's SD-WAN edge devices. These physical or virtual appliances connect branch offices, data centers, and cloud environments to the Cato cloud. The sockets support zero-touch deployment and can aggregate multiple WAN links for redundancy and load balancing. The third component is the Cato client, which is the endpoint agent that provides secure connectivity for remote and mobile users. The client supports Windows, macOS, Linux, iOS, and Android. It establishes an encrypted tunnel to the nearest Cato POP and provides zero-trust network access capabilities along with optional endpoint protection. The fourth component is SSE 360, Cato's converged security stack. This includes firewall as a service, secure web gateway, intrusion prevention system, cloud access security broker, data loss prevention, zero-trust network access, and remote browser isolation. All of these capabilities run within the single-pass cloud engine at each point of presence. Finally, we have the Cato management application, which provides the single pane of glass for configuring all policies, monitoring network and security analytics, and performing troubleshooting across the entire deployment. Global Private Backbone Architecture. Let me walk through the architecture of Cato's Global Private Backbone and explain why it is so critical to delivering the SASE promise. The backbone is not just a collection of point-of-presences, it is a carefully engineered private cloud network. The Cato backbone consists of over 85 points of presence distributed globally. These points of presence are hosted in Tier 1 physical data centers operated by providers like Equinix, Digital Realty, and regional equivalents. This ensures physical security, power redundancy, and connectivity diversity at each location. Each point of presence is interconnected with multiple Tier 1 global and regional carriers. Cato maintains SLA-backed IP transit services with these carriers, guaranteeing 99.999% availability and minimal packet loss. The software at each point of presence continuously monitors all available paths between points of presence, measuring latency, jitter, and packet loss in real time. When traffic needs to traverse the backbone, Cato's routing software selects the optimal path based on current network conditions. This is not simple shortest path routing. The system considers the actual measured performance of each carrier path and can instantly switch to alternate paths if conditions degrade. This delivers much better performance than the unpredictable public internet. The backbone is also self-healing. If a point of presence experiences issues, connected sites and users are automatically migrated to alternate points of presence without customer intervention. Cato reports that during real-world outages, customers experienced only seconds of disruption as connections seamlessly failed over. From a cost perspective, the backbone provides an alternative to expensive MPLS services. Customers can achieve enterprise-grade global connectivity using affordable internet links at each location, with Cato's backbone providing the predictability and performance that MPLS traditionally offered. Cloud and data center connectivity. Let me explain the options for connecting cloud environments and data centers to the Cato SASE platform. Modern enterprises typically have a mix of on-premises data centers and cloud workloads, and Cato provides multiple integration methods for each scenario. For cloud data centers in AWS, Azure, or Google Cloud, the primary option is deploying a Cato vSocket. The vSocket is a virtual appliance that provides the same SD-WAN capabilities as the physical socket. You deploy it as a virtual machine instance within your cloud VPC or VNet. Once connected, your cloud workloads gain access to the full Cato network and security stack. An alternative approach for cloud connectivity is using direct cross-connects from the cloud provider to a Cato point of presence. Many Cato points of presence are co-located in the same physical data centers as AWS, Azure, and Google Cloud availability zones. This enables private, low-latency connectivity without traversing the public internet. This approach can eliminate the need for premium cloud connectivity services like AWS Direct Connect or Azure Express Route. For environments that already have IPsec-capable edge devices, such as existing routers or firewalls, you can establish IPsec tunnels directly to the Cato point of presence. While this approach does not provide the full SD-WAN capabilities of a socket, the traffic still benefits from Cato's security inspection and optimized routing through the backbone. Once cloud resources are connected to Cato, all traffic to and from those resources flows through the Secure Service Edge 360 security stack. This provides consistent security inspection for cloud workloads using the same policies that protect branch offices and remote users. The unified approach eliminates the complexity of managing separate cloud security tools. Cato also optimizes access to software as a service applications through a smart egress capability. You can configure application-level rules to exit traffic at the point of presence closest to the software as a service provider's instance that serves your organization. This reduces latency for cloud application access while maintaining full security inspection. Universal Zero Trust Network Access. Let me dive deeper into Cato's implementation of Zero Trust Network Access, which they call Universal ZTNA. The universal aspect is important because it applies zero trust principles consistently regardless of where the user is connecting from. Traditional Zero Trust Network Access solutions focus primarily on remote access scenarios, replacing legacy VPNs for users outside the office. Cato takes a broader approach with Universal Zero Trust Network Access, enforcing the same identity-based access policies whether the user is remote, at home, or sitting in a branch office behind a socket. This eliminates the inconsistency of having different access models for different locations. The diagram illustrates the Zero Trust Network Access broker architecture. When a user initiates a connection through the Cato client, the request goes to the Zero Trust Network Access broker running within the Cato cloud. The broker authenticates the user against the configured identity provider and evaluates the device posture. Based on the user's identity, role, device status, and other contextual factors, the broker determines which applications the user is authorized to access. On the application side, Cato provides app connectors that publish private applications to the ZTNA broker. These connectors can be deployed as part of a socket or vSocket at the data center, or as lightweight agents installed directly on application servers. The app connectors initiate outbound connections to the ZTNA broker, which means no inbound ports need to be opened in the data center firewall. Applications are presented to users as virtual IP addresses, abstracting the actual internal network topology. Users only see and can access the specific applications they are authorized for. There is no broad network access like traditional VPN provides. If a user's device becomes compromised, the blast radius is limited to only the applications that user could access. Throughout the session, the Cato SASE 360 security stack continuously inspects all traffic for threats and policy violations. If suspicious activity is detected, the session can be automatically terminated. This continuous assessment is a key enhancement over one-time authentication models. ZTNA access methods. Let me explain the different access methods that Cato provides for Zero Trust network access. Different scenarios require different approaches, and Cato offers flexibility to accommodate managed devices, unmanaged devices, and clientless access. The primary access method is the Cato client installed on managed devices. This provides the most comprehensive security because the client can enforce device posture requirements, perform continuous posture assessment throughout the session, and optionally provide endpoint protection. For most employees using corporate devices, this is the recommended approach. For unmanaged devices, including bring your own device and contractor laptops, Cato offers the browser extension. The extension provides zero trust access without requiring a full client installation or administrative privileges on the device. Users install the extension in their browser, authenticate through the portal, and gain access to authorized web applications. IT maintains policy control while accommodating devices they do not manage. The third option is fully clientless access through a web portal. Users navigate to the Cato application portal, authenticate with SSO and MFA, and are presented with their authorized applications. They click to launch applications directly in the browser. This is ideal for external partners and contractors who cannot install any software on their devices. All three access methods connect to the same ZPA broker and are governed by the same policies defined in the Cato management application. An administrator defines who can access which applications based on user identity, group membership, device type, and other attributes. The policy applies regardless of how the user connects. This flexibility addresses a common challenge with legacy ZTNA implementations that require separate tools for different device types. With Cato, you configure the policy once and it applies universally across all access methods, simplifying administration and ensuring consistent security. SASE 360 Security Stack Overview. In this section, we will explore Cato's SASE 360 Security Stack in detail. SASE stands for Secure Service Edge, a term Gartner introduced in 2021 to describe the convergence of certain network security functions in the cloud. However, Cato's implementation goes beyond the standard SASE definition, which is why they call it SASE 360. Traditional Secure Service Edge as defined by Gartner includes three core components: Secure Web Gateway for protecting web traffic, Cloud Access Security Broker for controlling software as a service application access, and Zero Trust Network Access for securing access to private applications. These capabilities focus primarily on protecting users accessing web and cloud resources. Cato's SASE 360 extends this scope significantly. In addition to SWG, CASB, and ZTNA, Cato includes a full firewall as a service with application-aware controls, an intrusion prevention system for threat detection, next-generation anti-malware for file-based threat prevention, DNS security for blocking malicious domains, and remote browser isolation for protecting against web-borne threats. The key differentiator is that SSE 360 inspects all traffic, not just web and software as a service traffic. This includes WAN traffic between branch offices, east-west traffic within the network, and traffic from Internet of Things devices and other non-user endpoints. This comprehensive visibility ensures that threats cannot hide in blind spots that traditional SSE solutions would miss. All of these capabilities run within the single-pass cloud engine at every Cato POP. There is no need to size, deploy, or maintain separate security appliances. Cato handles all updates, patches, and threat intelligence distribution automatically, ensuring your security posture remains current without operational overhead. WAN and Internet firewall policies. Let me walk through how Cato structures firewall policies and the distinction between WAN firewall and Internet firewall rule bases. Understanding this structure is essential for effective policy design. The WAN firewall controls traffic flowing between sites connected to the Cato cloud. This includes branch-to-branch traffic, branch-to-data center traffic, and traffic between network segments. By default, Cato implements an implicit deny policy, meaning traffic between sites is blocked unless you explicitly allow it. This default deny approach aligns with zero trust principles. When creating WAN firewall rules, you specify the source, which could be a site, user, group, or network segment. You then specify the destination, which could be another site, specific hosts, or application services. The rule action determines whether to allow, block, or prompt the traffic. You can also specify which applications or services the rule applies to. The Internet firewall controls traffic destined for the Internet, including websites, software as a service applications, and external services. This is where you enforce acceptable use policies, block risky categories, and control application access. The Internet firewall integrates tightly with the secure web gateway and CASB capabilities. Cato provides predefined uniform resource locator categories covering thousands of websites organized by type, such as social media, gambling, adult content, and malware distribution. You can allow or block entire categories, or create custom rules for specific domains. The firewall also recognizes thousands of applications, allowing you to permit Slack while blocking Discord, for example. Both rule bases support logging and notification options. You can configure rules to generate events for monitoring, send alerts to administrators, or trigger automated responses. The logs include rich context about the traffic, including user identity, device, location, and application details. Intrusion Prevention System (IPS). Let me explain the intrusion prevention system capabilities within SSE 360. The IPS monitors all network traffic for malicious patterns and actively blocks attacks in real time. Cato's IPS uses a signature-based detection engine combined with protocol validation and anomaly detection. The signature database contains thousands of rules that identify known attacks, exploits, and malicious traffic patterns. Cato's security research team, called Cato CTRL, continuously updates these signatures as new threats emerge. The IPS inspects traffic at multiple protocol layers. At the network layer, it detects port scans, denial of service attempts, and network-based exploits. At the application layer, it identifies SQL injection, cross-site scripting, command injection, and other application attacks. It also detects exploitation attempts against known vulnerabilities in common software and systems. When the IPS detects malicious traffic, it takes immediate action based on your configuration. The default action for high-confidence threats is to block the traffic and terminate the session. For lower confidence detections, you can configure the IPS to alert without blocking, allowing you to investigate before taking action. The IPS also performs protocol validation to detect evasion techniques. Attackers often manipulate protocol headers or use non-standard encodings to bypass security controls. The IPS validates that traffic conforms to protocol specifications and flags anomalies that could indicate attack attempts. Cato provides different IPS protection profiles that balance security and performance. The recommended profile provides comprehensive protection suitable for most environments. You can also create custom profiles that enable or disable specific signature categories based on your environment. For example, if you do not run any Windows servers, you might disable Windows-specific vulnerability signatures to reduce processing overhead. Cloud Access Security Broker, CASB. Now let me explain the Cloud Access Security Broker capabilities within SSE 360. CASB provides visibility and control over software as a service application usage across your organization. The first function of CASB is shadow IT discovery. Employees often adopt software as a service applications without IT approval, creating security and compliance risks. Cato's CASB analyzes all cloud traffic to identify which applications are in use, who is using them, and how much data is being transferred. This visibility allows IT to understand the actual cloud footprint, not just the sanctioned applications. Cato maintains a database of thousands of cloud applications with risk ratings. Each application is scored based on factors like security certifications, data handling practices, terms of service, and known vulnerabilities. The CASB dashboard shows you which high-risk applications are in use, allowing you to take action to either sanction, coach, or block those applications. For sanctioned applications, CASB provides granular activity control. Rather than simply allowing or blocking an application, you can control specific actions within the application. For example, you might allow users to view files in Box but prevent downloading to unmanaged devices. Or you could permit uploads to corporate SharePoint while blocking uploads to personal OneDrive accounts. CASB policies can be based on user identity, device posture, and data sensitivity. A common use case is allowing full functionality on managed corporate devices while restricting actions on BYOD devices. You might also apply stricter controls when sensitive data classifications are detected in the content being accessed. The inline CASB architecture means policies are enforced in real time as users interact with cloud applications. Unlike API-based CASB solutions that only see sanctioned applications, Cato's inline approach provides visibility and control over all cloud traffic, including unsanctioned applications that would otherwise be invisible. Remote Browser Isolation (RBI). Let me explain remote browser isolation, which provides an additional layer of protection against web-borne threats. RBI is particularly valuable for high-risk browsing scenarios where traditional security controls may not be sufficient. Remote browser isolation works by executing web content in a secure, isolated container in the Cato cloud rather than on the user's device. When a user visits a website protected by RBI, the actual web page renders in a remote browser session. Only a visual stream of the rendered page is sent to the user's local browser. Any malicious code, exploits, or drive-by downloads execute in the isolated container where they cannot affect the user's device. The isolation is complete. JavaScript, browser plugins, and any executable content run only in the remote container. Even if a website contains zero-day exploits targeting the browser, the user's actual browser and operating system are never exposed. When the browsing session ends, the container is destroyed along with any malware that may have been present. Cato integrates RBI as an action within Internet firewall rules. You define which traffic should be isolated based on URL category, domain, risk score, or other criteria. Common use cases include isolating uncategorized websites where reputation is unknown, isolating potentially risky categories like advertising or file hosting, and providing safe access to webmail where phishing links are common. The user experience with RBI is designed to be seamless. Pages render with full fidelity, and normal interactions like clicking, scrolling, and form submission work naturally. For most websites, users cannot tell the difference between isolated and direct browsing. Some advanced web applications may have reduced functionality in isolation mode, so you balance security and usability when defining RBI policies. RBI also provides data protection benefits. Since content executes remotely, you can configure RBI to prevent downloading files, copying text, or printing content from isolated sessions. This prevents data exfiltration even if users visit unauthorized sites. TLS inspection and security processing. Let me cover TLS inspection, which is critical for effective security in a world where most traffic is encrypted. Without TLS inspection, threats hiding in encrypted traffic would bypass your security controls entirely. TLS inspection, also called Secure Sockets Layer Inspection or HTTPS decryption, allows the Cato security stack to examine encrypted traffic. When traffic arrives at a Cato POP, the Space Engine terminates the TLS session from the client, decrypts the content, performs full security inspection across all engines, re-encrypts the traffic, and establishes a new TLS session to the destination. This man-in-the-middle approach requires trust management. Client devices must trust the Cato certificate authority so that connections to the Cato cloud are accepted without certificate errors. For devices using the Cato client, certificate deployment is handled automatically. For devices behind SOCs, you deploy the Cato CA certificate through your certificate management solution or group policy. Not all traffic should be inspected. Some applications, particularly banking and healthcare applications, may have compliance requirements that prohibit TLS inspection. Some applications use certificate pinning that prevents inspection. Cato allows you to configure bypass rules for specific destinations, applications, or categories that should not be inspected. Cato maintains a default bypass list for domains that are known to have compatibility issues with inspection or where inspection is inappropriate. This includes major banking sites, government sites, and applications with certificate pinning. You can customize this list based on your requirements. The performance impact of TLS inspection in Cato is minimal because the Space Engine is purpose-built for this workload. Unlike appliance-based solutions where TLS inspection can severely impact throughput, Cato's cloud-native architecture scales compute resources to handle inspection without bottlenecks. Each space instance can process up to 3 gigabits per second of traffic with full TLS decryption. Cato Management Application Overview. In this section, we will explore the Cato Management Application, commonly called the CMA. The CMA is the unified console for managing your entire Cato SASE deployment. Everything from network configuration to security policies to analytics is accessible through this single interface. The CMA is a cloud-hosted application that requires no software installation or infrastructure to manage. You access it through a web browser from anywhere. Because it is cloud-native, updates and new features are delivered automatically by Cato. You always have access to the latest capabilities without any upgrade projects. The CMA interface is organized around 6 primary navigation areas. The Home section provides dashboards and overview information about your deployment. The Network section is where you configure sites, sockets, and network connectivity. The Access section handles user authentication, client deployment, and Zero Trust network access configuration. The Security section contains all security policies including firewalls, threat prevention, and data protection. The Resources section manages shared objects like groups, IP ranges, and application definitions. Finally, the Accounts section handles administrative settings, user roles, and licensing. One of the key benefits of the CMA is that all Cato capabilities, both current and future, are developed in alignment with this single management interface. When Cato releases new features, they appear in the CMA automatically. This ensures a consistent operational experience as you adopt additional capabilities over time. The CMA also supports role-based access control, allowing you to delegate specific administrative functions to different team members. You can integrate with your identity provider for single sign-on and enforce multi-factor authentication for administrator access. Network configuration in CMA. Now let me explain how you configure network connectivity through the CMA. The network section is where you define sites, manage socket deployments, and configure routing and bandwidth settings. When adding a new site, you start by defining the site properties including name, location, and site type. Site types include branch office, data center, headquarters, and cloud data center. The site type influences default settings and how the site appears in analytics. For each site, you configure the socket or vSocket that provides connectivity. You specify the WAN links available at the site, including the bandwidth of each link and whether it is the primary or backup connection. The CMA tracks socket shipments and deployment status, so you can monitor rollouts across your organization. Network ranges define the IP subnets behind each site. You configure the LAN ranges and specify routing options. Cato supports both static routing and BGP dynamic routing for integration with existing network infrastructure. If you have multiple subnets at a site, you can configure network segmentation to control traffic flow between segments. Bandwidth management settings control how Cato allocates capacity across your sites. You can set bandwidth limits per site and configure quality of service policies to prioritize critical applications. The quality of service engine ensures that latency-sensitive traffic like voice and video receives priority over bulk transfers. The network section also includes tools for troubleshooting. The packet capture feature allows you to capture traffic at any site for analysis. The traceroute tool shows the path traffic takes through the Cato backbone. These tools help you diagnose connectivity issues without needing direct access to remote sites. Extended Detection and Response, XDR. Now let me cover Cato's Extended Detection and Response capabilities, which provide advanced threat detection and incident response within the same platform. XDR represents the evolution of security operations, correlating data across multiple domains to identify sophisticated threats. Cato XDR is built on the same data lake that powers the rest of the platform. It ingests events from the network security stack, including firewall logs, IPS alerts, malware detections, and CASB events. It also incorporates endpoint telemetry from the Cato Client EPP/EDR engine. This unified dataset enables correlation across network and endpoint domains. The detection engine uses AI and machine learning models to identify anomalous behavior and potential threats. These models are trained on data from across the Cato customer base, enabling detection of attack patterns that might not be visible within a single organization. The models continuously improve as they process more data. When the detection engine identifies a potential incident, it creates a story in the XDR workbench. A story groups related indicators and events into a coherent narrative. Rather than reviewing hundreds of individual alerts, analysts see consolidated stories that show the full scope of suspicious activity. The XDR workbench provides investigation tools integrated directly into the CMA. Analysts can drill down into any event, pivot to related activity, and view the full context of the incident. Timeline views show how the attack progressed. Entity views show all activity associated with a specific user, device, or IP address. Response actions can be initiated directly from the workbench. You can block malicious IPs, quarantine compromised endpoints, or disable user accounts. These actions are executed immediately across the Cato platform without needing to access separate tools. This tight integration between detection and response accelerates incident handling. Remote user deployment. Now let me cover the workflow for deploying the Cato client to remote users. This process enables secure access for work-from-home employees, mobile workers, and traveling users. The deployment approach depends on how devices are managed in your organization. For devices managed through an MDM solution like Microsoft Intune, VMware Workspace ONE, or Jamf, you deploy the Cato client as a managed application. The MDM pushes the client to devices along with the configuration profile that points to your Cato account. For organizations without mobile device management or for contractor devices, Cato provides a self-service portal. Administrators generate invitation links that can be sent to users. When users click the link, they are guided through downloading and installing the client. The installation process is simple enough that most users can complete it without IT assistance. User authentication is configured in the Access section of the CMA. You integrate Cato with your identity provider for single sign-on. Cato supports major identity providers including Azure Active Directory, Okta, OneLogin, and others via SAML or OIDC protocols. Multi-factor authentication is configured through your identity provider and enforced during Cato client login. Device posture checks are defined in the Access section. You specify the compliance requirements that devices must meet, such as minimum operating system version, antivirus status, and disk encryption. Devices that fail posture checks can be blocked entirely or given limited access depending on your policy. Once deployed, the client automatically connects to the nearest Cato POP whenever the device has internet connectivity. Users do not need to manually initiate connections. The always-on mode ensures that all traffic is protected without user intervention. For situations where users need to disconnect, you can configure the client to allow manual disconnection or enforce always-on based on your security requirements. High availability and resilience. Let me explain the high availability features built into the Cato platform. Resilience is critical for enterprise networks, and Cato provides multiple layers of redundancy at both the site level and within the cloud infrastructure. At the site level, sockets support multiple WAN links in an active-active configuration. Traffic is distributed across all healthy links, and if one link fails, traffic automatically moves to the remaining links. The socket continuously monitors link quality and can proactively move traffic away from degrading links before they fail completely. For critical sites, you can deploy two sockets in a high availability pair. One socket operates as primary while the other stands by ready to take over. If the primary socket fails, the standby assumes the primary role within seconds. The failover is transparent to users and applications. Within the Cato Cloud, resilience is built into every layer. Each point of presence contains multiple compute nodes running multiple SPACE instances. If a SPACE instance fails, traffic is automatically distributed to other instances in the same point of presence. If an entire compute node fails, the point of presence continues operating on the remaining nodes. At the point of presence level, Cato maintains connectivity through multiple Tier 1 carriers. If a carrier experiences issues, traffic routes through alternate carriers. If an entire point of presence becomes unavailable, connected sites and users automatically migrate to alternate points of presence. Cato reports that during a real point of presence outage, customers experienced only 30 seconds of disruption during the automatic failover. The Cato backbone itself is designed for resilience. Traffic between points of presence can take multiple paths through different carriers. The routing software continuously evaluates path quality and selects optimal routes. This dynamic routing ensures that backbone issues do not impact customer traffic. Cato's SLA guarantees 99.999% availability for the cloud platform. This 5 nines availability translates to less than 6 minutes of downtime per year. The SLA is backed by service credits if availability targets are not met. Best practices and summary. Let me conclude this presentation with best practices for Cato SASE deployments and a summary of what we have covered. For security configuration, start with Cato's recommended settings and adjust based on your requirements. Enable TLS inspection broadly but configure bypass rules for applications that require it. Use the best practices page regularly to identify configuration gaps and maintain a strong security posture. For network design, leverage multiple WAN links at each site for resilience. Use Cato's quality of service capabilities to prioritize business-critical applications. Monitor the experience dashboards to identify and address performance issues proactively. For user deployment, integrate with your identity provider for seamless authentication. Define clear device posture requirements and enforce them consistently. Consider always-on mode for the Cato client to ensure continuous protection. For operations, take advantage of the unified management model. All configuration and monitoring happens in the CMA, eliminating the need to manage multiple tools. Use the API for automation and integration with your IT service management processes. Throughout this presentation, we have covered the complete Cato SASE platform. We examined the core architecture including the single-pass cloud engine and global private backbone. We explored connectivity options through sockets, vSockets, and the Cato client. We detailed the SSE 360 security stack with its comprehensive threat prevention and data protection capabilities. We walked through the Cato management application and its analytics and configuration capabilities. Finally, we discussed deployment strategies and operational best practices. Cato delivers on the SASE promise by providing secure and optimized access for everyone, everywhere, at any scale, and to any application. The converged, cloud-native architecture eliminates the complexity of managing disparate point solutions while delivering enterprise-grade security and performance. Thank you for your attendance. Please consider subscribing to the channel and liking this video.